Chapter 4.4, Day 1, Factoring Polynomials. In the previous lesson, you factored quadratic polynomials. Quadratic polynomials means degree 2 polynomials. You can also factor polynomial with degree greater than 2. Some of these polynomials can be factored completely using techniques you have previously learned. A factorable polynomial with integer coefficients is factored completely when it is written as a product of unfactorable polynomials with integer coefficients. So what it means we are going to show through the example. So I'm going to use help of examples to explain how we can factor different type of polynomials with different methods. Let us do example number 1, letter A, x cubed minus 4x squared minus 5x. Whenever you see any polynomial, first thing you always see is that if any common monomial or common number can be factored or not. So if you notice here, the common monomial in this one is x because x is present in every term. So you can factor the x out. Inside you're left with x squared minus 4x minus 5. Whenever it becomes into a quadratic, so this inside is a quadratic, you can always apply a cross method. So the cross method is you have -5 on the top and -4 on the bottom. Two numbers that you're looking for are going to be -5 plus 1. -5 times 1 is -5 and -5 plus 1 is -4. So the factors are going to be, so remember the x is going to be as it is. So x outside, and then the two factors are x minus 5, x plus 1. So your complete factors are x times x minus 5, x plus 1 for this polynomial. Now we are going to only write this into a factor form. If this is equal to 0, then we will go ahead and solve for x. But in this case, it's just asking us to factor, not solve for x. So we're going to leave the answer right here. For the next polynomial, 3y to the 5 minus 48y to the third, we are going to find out the common monomial or common factor. So you can see that here is a common monomial, that is 3y cubed. So 3y cubed is common monomial. You're going to divide both the terms by 3y cubed, and you're going to get the factor as 3y outside, and inside you have y squared minus 16. Now y squared minus 16, that's our aim to solve. Y squared minus 16 is 3y cubed as it is. That's going to be y minus 4 times y plus 4. Remember the formula that I applied for this one is a squared minus b squared, the difference of square formula. A squared minus b squared is a minus b times a plus b. So the only difference is that we have, instead of b squared, we have 4 squared. So y squared minus 4 squared becomes y minus 4 times y plus 4. Just like a minus b times a plus b. Next question is letter C, where you're going to factor this polynomial, which is 5z to the 4 plus 30z to the third plus 45z squared. Now, if you look at the numbers, you can see that the 5 is the number that is common in each term. So you're going to divide each term by 5. And then the variable that is common, so each term has at least z squared in it. So z squared is also that the variable that you want to divide each term with. So 5z squared is going to be your common monomial. So common monomial is 5z squared, and now we're going to factor the 5z squared outside. So the 5z squared times, inside you're going to left with z squared plus 6z plus 9. Now if you notice, this equation becomes a second degree a quadratic equation. You can solve it by using the cross method. On top of the cross is 9, on the bottom is 6. The two numbers that you're looking for, which multiply to be 9 and add to be 6, is 3 and 3. So your factors or complete factors are going to be 5z squared as it is. So this 5z squared as it is. And these two will make other two factors. So that's going to be x plus 3 times x plus 3. So that's going to be your answer in the box. Next is you try problems, and we are going to do letter A. So in letter A, the common factor, common monomial is x that you can factor out. So if you factor out the x from here, you're left with x squared. Factor out the x from here, you're left with 10x. And if the factor out x from here, you're left with 24. Make a cross, and on top of cross, you get 24. And the middle term goes on the bottom, so that's going to be 10. You're looking for two numbers that multiply to get 24, add to get 10, are 6 and 4. This x remains as it is, and the other two factors are x plus 6 times x plus 4. So this is a complete factorization of this polynomial. Next is letter B. The common monomial for this function or this polynomial is 5y to the 4. So they both can be divided by 5, and they both can be divided by y to the 4. So the common monomial will be outside. Inside the bracket, you're left with here 5 is gone, y to the 4 is gone, you're left with y square. And here 125 divided by 5 is 25. Y to the 4 divided by y to the 4 is just 1. So we just write 25. This expression 5y to the 4 remains as it is. And here you're going to apply a square minus b square. So that's going to be a minus b times a plus b. So this is going to be your complete factorization of the polynomial 5y to the 6 minus 125y to the 4. Next is 6z squared minus 24z plus 24. If you notice, in all of these numbers or terms, you can see that the 6 is a common monomial. So you can factor the 6 out. So 6 out. You left with z squared. Here you left with z squared. 24 divided by 6, you left with here negative 4. And plus 4. Now you're going to factor. You make a cross. On the top of the cross, you write the last number, that is 4. And on the bottom, you are writing the middle term, that's negative 4. The two numbers that you're looking for, when you multiply, you get 4. When you add, you get negative 4. So the two numbers are negative 2 and negative 2. Your 6 remain as it is outside. Other two factors are going to be z minus 2 times z minus 2. So the complete factors of polynomial 6z squared minus 24z plus 24. Next, we are going to do special factoring patterns, and we are using a cube plus b cube, so sum of two cubes. I got this formula we discussed earlier, that is a cube plus b cube is a plus b times a square minus ab plus b squared. So we are going to use this formula to solve this example. So first of all, I'm going to write this into a cube plus b cube form. So for that, I'm going to use 64 cube as 4x cube. So that's a cube. And I'm going to use 1 as b cube. So 1 cube. Now I'm going to write down the formula a plus b. So that's my a cube plus b cube. That's going to be a plus b times a square minus b plus b squared. So that's going to be a plus b times a square, which is 4x squared, minus ab, a times b plus b squared. So the final answer is 4x plus 1, 16x squared minus 4x plus 1. So this is going to be your complete factors for 6x cubed plus 1. I'm going to use the difference of two cubes, which is a cube minus b cube. And when you expand it, I got the formula that we already discussed, that is a minus b times a squared plus ab plus b squared. So first of all, we need to write this in the form of a cube minus b cube. So I'm going to use the 27x cubed as 3x cubed minus, I'm going to use 8 as 2 cubed. So what I got here is a minus b, so 3x minus 2, 3x squared, which is a squared, plus ab plus a b plus b squared. So that's going to be 3x minus 2, 9x squared, plus 6x plus 4. Complete factors of the polynomial 27x cubed minus 8.